Did you remember my advice about ln and rewrite it as log base e? Because if you did, I bet you would have figured out that the bases were the same. You know, if that and that are the same, then the answer's 5. And that's all there is to it. Raise your hand if you had 5. Okay, good. Next one is ln1. Ooh, 1 in the argument, you get nothing. The end. Okay, next one. This. Where should I put that 4? Because I'm tempted to rewrite it, but it's too weird in two ways. There's a 4 in front of it, and there's no base. So what's the base, actually? 10. And then where should I put the 4? Up on the x. And then I can do a rewrite, aka use the circle of logs to get rid of the log. And look, no more log. And then it's just about getting the x alone. And then if I just put it to the power of what? 1/4, then this is gone. And careful, did you remember absolute value of x? Raise your hand if you did. Oh, I got a lot of you. You just put it to a even root. That's like a square root, and that means there's 2 answers, positive and negative. But wait, we'll see if there's a chance that one of them is extraneous. All right, now this is 2 times 1/4, which is 2/4, which is 1/2. That's 10 to the 1/2. Doesn't that also mean square root of 10? It does. Okay, so your answer is the square root of 10, except you got this pesky absolute value, which most everybody forgot because we had an even root on both sides. Now I've got 2 answers, the square root of 10 and the negative square root of 10, because that's what it means. It means square root of. Now, if you had a calculator, you'd get a decimal for it, and it'd be some decimal that multiplies to 10. Okay, so then what do? I look at the original problem, and I see, would it be in the original problem, like very original, like back when there was a 4 in the front and not as a power, could the negative square root of 10 be allowed in here? No, not in the original problem. So then that one gets thrown out. And I know some of you are going to be like, oh, phew, I said this one, so I'll get credit. No, you have to say both of them, and then you have to say that one's extraneous. That was vicious, I know. And if you put it as 10 to the 1/2 power, I would have accepted it. I don't expect you to know the square root of 10 in your head. So you could write this as 10 to the 1/2. That's fine. All right. Okay, and then there's this one. Oh, wait, then there's this one. Okay, sorry. On this one, you would combine the 2 logs into 1 log, and it's, of course, base 3. And then you multiply when they're added like this. X times x minus 6 equals log base 3 of 7. And then a beautiful thing happens. Since these are the same log bases, I can focus on that. That equals 7. But you can't solve a quadratic until it's set equal to 0. So I'm going to subtract 7 from both sides. And now it'll equal 0. And here's my actual quadratic. X squared minus 6x minus 7 equals 0. And does it look like maybe that would factor? That's usually how we do it. Is so that when you get it set equal to 0, it just factors. X, and there's a negative at the end, which has to be plus and minus. And then what multiplies to 7? It's got to be a 7 here and a 1 here. If you don't know why, you better talk to me about how to factor. And there's 2 answers, -1 for this and 7 for that. Which one are you suspicious of? -1. Because again, there's 2 answers, one of which will kill the original equation. Do you get if you put a -1 right here, you'll have a log base 3 of an argument that's negative, and that's not allowed. Cross it off, ext. If you don't have an extraneous on your test, I will be shocked. Because they come up a lot in this unit. Because logs can't have negative bases or arguments, and you got to watch out for that. All right, and now there's this one. You didn't see it before, but this problem is now your new challenge. The question is, do you know how to graph that? Because if you don't, at least you got to be able to find a few points and the asymptote And once you graph 3 points in the asymptote, you'd be fine. So let's not even graph because you don't have graph paper. But could you get me 3 points and the asymptote? For the asymptote, I'm going to remind you that the log starts like this. This is a normal one. And the asymptote is here. If you move the asymptote up, it won't even move. Like it's going to be right on top of itself. So the only way the asymptote would actually change from being at x equals 0 is if it got moved to the right or the left. And this problem does move. So you should know where the asymptote moves to. The 4 does not affect the asymptote. All right, I'm going to pause for another minute while you try to find 3 points in the asymptote. Okay, by now you either know how to get the points and you've got them, or you need me to show you. So this was, the blue graph I had was just kind of a general log graph. That's kind of how they look. But our exact points would be, if I put in a 1, that would be smart because I did it in my head and I made it like, oh, that made the inside 0, that is the asymptote. If it makes the inside 0, that makes the asymptote. The other way you can think of it is the asymptote needs to move to the right 1. So x equals 1. Do you want to think of it that way? Either way, that's how you find the asymptote. Make the inside be 0. Next, I'm going to put in 0 and realize you can't put in 0 because then you'll have a negative argument. 0 just doesn't work, so I'm throwing out 0. 1 was the asymptote. 0 didn't work, so I guess I got to move in the other direction. I got to put in like 2 because 0 didn't work. Negatives aren't going to work. All right, so now I'm putting in a 2. 2 goes in, and I got a 1 in the argument spot. Ooh, I know that answer. I won the argument, you get 0, and even 4 times 0 is still 0. And then I'm going to put in a 3. And if I put in a 3, 3 minus 1 is 2. Log base 2 of 2 is supposed to be easy. Log base 2 of 2 is 1. You times it by the 4 in the front, you get 4. Is that 3 points in the asymptote? No, that's the asymptote and 2 points. I need 1 more point. But as soon as you put in 4, I hope you realize that was not a good decision. When you put in 4, 4 minus 1 is 3, and log base 2 of 3, I don't even know how to do that. It's some decimal I'd have to look up on a chart somewhere or use a calculator for, so 4 is a bad idea. So I would try 5. I'm putting 5 in because 5 minus 1 makes 4. Log base 2 of 4 is 2. 2 times the 4 makes 8. 5 comma 8. Those would be the logical points. Is there any other points possible? Yes, but they'd be weird like fractions. You could make this whole thing turn into 1/2. It's kind of a cool idea. To make it turn into 1/2, you'd have to use 1 1/2 for x. I'm curious, did anybody do that? Awesome. I'd predict that you will do very well on the test because that's advanced thinking there. If you figured out how to make this into 1/2, that was very strategic thinking, like, oh, because then the answer would come out -1. And so how do I make it 1/2? And then you'd have to put in 1 1/2 right there to make it be a half. All right. Is there anything else on the test? Oh, of course there is. And we'll do a little bit more review here. But mostly for today, I've given you a practice test and a whole bunch of time. And I'm going to do the deal again where I'm going to say it's a fairly decent sized practice test. I'm going to have you skip any 4 problems, but I would personally skip ones that seem easy but tedious. Don't skip anything scary, or you're on purpose not practicing the one you're probably going to get wrong tomorrow. So skip anything on the homework. 4 problems, any 4 problems that feel like they would take a long time, but you know how to do them. All right, so your homework is that worksheet. But before we get there, a couple last like little problems that things you have to know how to do. Sometimes it freaks kids out when it's all variables. log base m of p equals q. What could you even do with that? Don't say it, write it. This is the number one skill for the test. M to the Q equals P. See, it was a log, now it's not a log. That's what's critical, is can you take them back and forth between things that aren't logs and turn them into logs, things that are logs, taking the log out. Now, is this one solved for something? Maybe you don't know what that word means, or you'd say, yes, it is solved for something. What is it solved for? P. Good. That's solved for P. What if I wanted to solve it for M? You'd put it to the power of 1 over Q. Now the M's alone. I solved it for M. All right. Last thing I want to talk more about is LNs, because it was kind of the last new thing and we really haven't done too much with it. Do you know the answer yet? How do people know those so fast? They just in their head quick go, ooh, he said that that's log base E, and then they go, ooh, I see the pattern, and the answer is 7. Okay, how about this? Ln of the third root of E. Ew. What's that answer? Don't say it. And if you don't know, maybe you should write it down and do what I always said to do with LNs. I said to make this into log base E. And then hopefully you'll realize, oh, so you really just need me to make that into e to a power, and it's e to the 1/3 power. So the answer is 1/3. Raise your hand if you had 1/3. Nice. Okay. And last, we've already done one like this, but let's do one last kind of condensed kind of question. Log base 5 of 3 minus log base 5 of x is equal to 7. Solve. Wait, stop. Put a 2 right here. And that'll prevent you from just like slapping them together super quick. You got to know what to do with the 2. That's 2 log base 5 of x. All right, in case that stumped you, that 2 is supposed to go up as a power on this x. Raise your hand if you knew that. Okay, awesome. Remember that. That's called the power rule. Super handy. Because now you can squish these 2 together. And it's a minus, in case you missed the memo there, that's a minus. So then this is 3 over x. 5 to the 7th, ooh, it's even got one of those in it, equals 3 over x. 5 to the 7th is huge. Realistically, you would not do that without a oh, something's wrong, I can tell. Yes?
Where'd the 2 go?
Okay, where'd the 2 go? What 2? Oh, you're right, it's squared, and so I should have a squared right there. Thank you. Just dropped it out, and then it's right there still. Just lost it. Sorry about that. Okay, now, one of my favorite sayings is if you can factor it, you should. So I'm honestly thinking, like, should I factor this? No. Another one of my favorite sayings is, can you clear the fraction? Yes, you can clear the fraction. So I'm going to times this by x squared on both sides. And that cancels that. Now it's not a fraction anymore. Now 5 to the 7 is just some really big number. I don't know what it is. It's just really big. Could I get it off of there to get the x squared alone? Yeah, I could just divide both sides by that. Divided by 5 to the 7th. Divided by 5 to the 7th. X squared equals 3 over 5 to the 7th. And that's just some ludicrously small number now because it's 3 over some huge number. And then let's just save some time. Did you remember that it was, you just did an even root, so you would have absolute value? Did you remember it, or did you get burned again? Okay. And then, this is really gross. We would have had these numbers work out nicer. Let's say that it was 9 over 25 to the 1/2 power. Let's say it was that. Would you have been able to do what 1/2 power means? Doesn't it just mean square root? So then this one would have been 3 over 5, so 3/5. But I totally faked this turning into this because I wanted it to work nice. All right, that's it. Now you got a ton of time to work. You got a practice test. You got a key for the practice test. Do the whole practice test except 4 problems that you think would be easy for you but tedious. So skip any 4, and that's all I got for you for today.